All right, here we are in Google Classroom looking at, eventually your assignments are going to be right at the top, but we're still in summer homework right now, so I'm just keeping it under summer homework. But for those that are wondering about, let's see, I did put Chromebook shortcuts in here for you. It's a PDF with all the shortcuts for Chromebook. So if you're wondering about any shortcuts, you can find them there. You need to make sure that you have a composition notebook. We are going to be starting to set this up. You need to have a composition notebook, please. That I sent out August 19th. And then I reminded you again on the syllabus that we're going to need a composition notebook. You're also going to need to have tape and scissors at all times because you can cut, like I just passed out the packet to Algebra 1. It's a packet for a whole month. It's got everything in here. It's got the notes in here, the guided notes. It's got the homework in here. I'm handing out one packet so that we're not going back and forth with paper. We are looking at where to find stuff about digital portfolio. If you're still having questions, it's not going to be under summer homework. It's going to be under math projects, digital portfolio. If you look in here, you're going to see that there are videos in here. Let's see. Okay, looking at your website. Hopefully you bookmark it. If you haven't, you can go to sites.google.com, find your website. We are putting 4 resources on here, so you're going to want to have a tab open for today, Monday, 9/21. Here are the 4 things that we're putting on there. Patrick, Just Math Tutorials, Purple Math, Math Bits Notebook, and Math Planet. Those 4 resources are going on your website. Here's the icon right now that I need you to do. It's the person with the plus sign. If you have not shared your website with me, you need to punch in mhall and you'll see me come up with a flag on it and then put done. You need to add me as a collaborator. That's why I don't have a grade in for you right now because I was not behind the scenes. All right, so pages, we're going to pages. And you always click this plus sign right here to create new pages. You should have a mathematics page and then you have Algebra 2 embedded within that. We're going to Honors Algebra 2, so math. This is where we're keeping all of our resources. So far, we have Flipgrid, Khan Academy, and Edpuzzle and our textbook in here. Right now, what we're going to do is we're going to go over here. We're going to click on Patrick, Just Math Tutorials. Let's open those pages up. I like this one because it's videos. You can search by content or you can look at the different things that are down here. If you need extra help on anything, if you just don't understand the topic that we went over, you can go in there and you can find that topic. We are going to click on the top. We're going to copy, Control C. Control C. We go to our website, go all the way to the bottom, double click, and embed is on the left in the yellow. Embed the URL, Control V. Insert, and it's only inserting it as a link. Yes, push OK anyways. It's not going to embed. We're going to see some other ones that actually give us a preview. Like if you look at Edpuzzle, these are previews. These 3 right here, they give us a nice preview, a nice icon. This one would not do it. Give me a thumbs up if you have that embedded so far. All right. Now, we're talking about design a little bit too, so I'm going to give you some little tips and tricks about what you can do. Right now, I actually want to create a header that says Algebra Resources, so we can double-click and do a text box, T. A text box brings up another section. So this is a section right here. You can see the dotted lines. I'm going to put in here, I'm going to put Algebra Resources. Designing ideas would be changing normal text. Click on it and let's make it a title so it stands out. Algebra Resources. I can highlight it and make it bold if I'd like to. And then you have centering right here, whether you want it all the way to the left or you want it centered. One last thing that I would like to do, because this is a section and my resources are going to be after that, is I would like to take and use my theme color there. Now it stands out. I have my digital textbook at the top. I can hover on the left-hand side, and I'm going to move this section to above Patrick. If I know that I'm wanting to have more sections with that same color, I can come over here, which I do. I'm going to put homework platform. I'm going to make one to go right before this that says homework platform. So I can just copy this, change it to homework. That way I don't have to go back and do all the colors again. Homework platforms. I just copied my algebra resources. Now I'm going to drag it to the top underneath my textbook. I'm going to take this and I'm going to drag it up and I'm going to put it right after my textbook. Now it separates it. There's my digital textbook with my username and password so I don't forget. I have a white section here to separate it. Then my next section is about the homework platforms that I work off of. This Holt McDougall should be up here with my textbook. Now I have Flipgrid, Khan Academy, and Edpuzzle. Those are the homework platforms that we use. And now we have some algebra resources. When I'm thinking about design, I'm like, this really looks offset. I don't like it like that. I could add a text box. And then I could highlight this, copy, and move it down one. And now if I look at it, now it's more centered a little bit. Those are just little tricks. Text boxes, sections, kind of help you even some things out. So there's my textbook. Here's my homework platforms. Here's my algebra resources. Now we're going to go back and we're going to get the other three. Practical algebra. Open that tab up. Purple Math, copy, Control C, go back to the website. I'm going to go down below the dotted line right here so it doesn't attach to this one right now. I'm going to come down all the way to the bottom, double click, embed. This one gives me preview. I love preview. Gives me a nice little picture that I can embed instead of just having a URL there. I'm going to embed it. But then it's got a lot of description with it that I'm going to shut off in a second. I'm going to shut off the description here. It looks horrible. I just want this right here. So if I click on it, I can see a settings wheel at the top. Show description. I'm going to shut that off. I don't want to see the description. What I'd like to say about, here's a workaround that I do when it doesn't say I can embed it. I can actually screenshot a picture and then link the picture to that person's website. So I look at the website and I say, all right, what is it on here that I would actually like to take a picture of? Just math tutorials, maybe Patrick with the sunglasses. So for you guys, a screenshot, you know how to take a screenshot? Give me a thumbs up if you know about screenshots on Chromebook. Thank you, thank you. You're going to do Control, Shift, and then it's the key that's above 6. It's the window key. Click. And then you drag and you outline what it is that you want to do. So go to your website, double click, and go to your drive. That's at the bottom, the drive. Open up the drive. We're going to arrow over right here, this little arrow that's here. We're looking for recent. If I arrow over, I can see recent comes right up. When you click on recent, you will see your screenshot, your partial screenshot there. We can link the picture, but before I link it, it's best to make sure you have the picture the size that you want it to be because it's hard to do that after you link it. So maybe I want this to be a little bit bigger. I can drag it out. Let's say the picture is all messed up and it looks like this. The middle one here is about focusing that into the picture. So first you do your length. Once you have it the length that you want it to be, then you use the middle one and you scroll in or out until you can actually see that picture. Everything in the picture. Once you have your picture all set, so copy the URL, and then you go to, you click on your picture, and there's the link right there. I can link a picture, copy it in there, and apply. You have 2 more math bits, and this last one is Math Planet to put on your resource page. I'm not going to do any more right now, though. On your real number system, you have the complex, which is new to Algebra 2. But before this class, you always knew about the real number system. Even the imaginary, you heard of it, but you didn't do too much with it. We're going to be using imaginary a lot. It's right in chapter 1 with quadratics. The quadratic formula, when it has a negative under a square root, like the square root of -4, we're going to be seeing that that's plus or minus 2 for the square root of 4, and then I for being imaginary. So we will be using that this year. You've been under the real number system your entire life. The real number system, okay, you have rationals, your fractions and decimals, and you have integers with your positive, negatives, and zeros. Then you have the whole set, 0 through infinity, and then the natural set, how you started naturally counting, 1, 2, 3. You should always start at the bottom with the natural set and work your way up through all the way to complex. Students are missing things like this. I love this example, -2 1/4. What set does -2 1/4? That's what people always say. Why do people say that? Because of the negative. So what you have to think about is, are there fractions in the integers? Then it can't start there. It has to follow all of it. Where's the first place you see a negative fraction? That? Right here. So this would be the very first place that it starts, and then it just keeps going up to the reals and up to the complex. So, I mean, it was very easy for me to diagram this out. If I was taking a test, I would just diagram it out, and I'd start right at the bottom, and every problem, I would just work all the way up until you find the place that it actually starts at, and then it continues going up the whole time. Yes, yes. The complex number system is everything, real and imaginary, and everything that falls under that. And let's see, I didn't do this right. Real and imaginary. Where's irrational? Oh, right here. Irrational would be a separate category here. It is substituted incorrectly. I would just do the numerator, get an answer, do the denominator, and then put them together. So everybody did fine on this part. They're like, okay, 8 divided by 3 times 8. I would do parentheses first, and then working from left to right, multiplication would come first. So really, parentheses comes first. After parentheses is multiplying. And then what do we have? 25, 4 times 16. Everybody did fine. It was after this point. After this point, people wanted to do 8 divided by 24. But PEMDAS says, if multiplying and dividing is in the same step, which one do I do first? What's the rule that goes along with PEMDAS for multiplying and dividing and for adding and subtracting? They have a condition. Which way? That's good. There's more to that. Whichever comes first. What, right to left? Left to right. So there's a condition with both of these. Whichever one occurs first, left to right. That's for both of these that have that condition. So if I look over here, dividing is first and then multiplying. So it's 8 divide 3. It's like 8 divide 3. I'm in a fraction right now. I'm just going to write 8 divide 3 like this. Write it like fraction. 8 divide 3 times 8 over 64. Finish this part. I'm not going to work with decimals. I'm just going to keep going. Make 8 a fraction. Multiply straight across. And we get 64 over 3 divided by 64. What do we call this? What is this called? 64 divide 3 divide 64. What is the definition word for this horrible looking thing? Huh? A fraction within a fraction. What is it called? Begins with a C. Complex fraction. This is called a complex fraction because I have a fraction in the numerator and I could make a fraction in the denominator. Fractions within fractions. How do we divide fractions? That's right. You flip and multiply, and you're using the reciprocal. Do I flip the first fraction or the second fraction? Second fraction. So this is 64 divided by 3 times 1 over 64. Look at that. I got a 64 in the numerator and a 64 in the denominator. I didn't have to do decimals and make it looking all messy. I can cancel and I end up with 1/3. But this part right here is the part that students always do 8 divided by 24. How do I get credit in Mrs. Hall's class? I see a problem like this, I have no idea what to do. But I could graph the point. I could at least demonstrate that there is a coordinate and I can put it on the XY plane. That right there is partial credit because you're doing something with the problem. Something is better than nothing. Once you graph it, then you go, okay, how can I get more points from Mrs. Hall? It says, write an equation of what? A vertical line. Going through that point. I could make a vertical line going through that point. Now you've got half credit for this problem just for demonstrating you can take written directions and you could do something with it. The final thing would be just to write an equation of the vertical line. X equals a number is vertical. Y equals a number would be a horizontal line. That is, I'm not saying that you're wrong, but my goal to open up your minds in Algebra 2 is to not have the crutch. That crutch would be my backup plan. Let's say that I tried to do it by critically thinking about it and doing the problem. I did it. I would use that as my backup plan because it's very solid in your mind. And there's nothing wrong with that. I was hoping that somebody was going to say that. You went through these steps. Like when I look at standard form, it's very easy. All I need is, how many points do I need to graph a line? I only need 2 points. 2 points determines exactly one line. If I have 1 point, I can have an infinite number of lines going through there. If I have 3 points, then I can draw 3 lines. If I have 2 points, it draws exactly 1 line. All I need is 2 points. So the point is, if I have standard form is awesome for finding an X and a Y intercept. All I have to do, what's going to make me land on the X axis? What makes me land there? If I land right here, what would be true about that? Exactly. I have an X and then I have Y is 0. What would make me land on a Y axis? I would have a Y, but I'd have to let X equal 0. If I look over here and I let Y equal 0, what's 6 times 0? It goes away. I can visually see 3x equals 12. It says 3x equals 12. What's x equal? 4. There's 1 point. Now if I let x equal 0, 3 times 0 is 0. It always goes away. That term literally goes away, and you're left with a one-step equation. 6y equals 12, y equals 2. I go and I plot 4, 0. Thank you. I plot 4, 0, and then I plot 0, 2. And I draw my line. It takes no work for a student to make 2 parentheses and let y equals 0 and x equals 0 and get those 2 points. Which student does more work, or like me, does it incorrectly? If you always convert to y equals mx plus b, you're narrowing your thought process. You want to keep it y. You want to have a lot of different ways to approach things. That would also be true of this formula. What form is this equation? What form is this equation in? Let's go with Emily. Point, slope. So what 2 things do you think I'm going to take out of this formula then? A point and the slope, and then I'm going to graph. I go through the algebra of distributing and then shifting everything to the right. So I need a point and I need a slope. What's the slope of this equation? 2/3. What is the point of this equation? It's always the opposite of the signs that you see here. Hey, at least you said your x first. Most students would say this is their x and this is their y because of the order that it was in. So you got your x and your y right. That's okay. So it would be 1, -2. You're taking the opposite. That's going to be true all year long for every single formula that we do. It's always going to be the opposite. So 1, -2. All right. It's called point slope. I'm going to use the point slope. Which one am I going to use first? So I need the point first. I go to 1, -2. And once I have a point, then I can rise and run the slope. Rise 2, run 3. 1, 2, 3. There's 2 points that determine a line. no work. Find the point slope and graph. That's what I mean about each formula has its uses. You're going to hear me say this again when we get to degree 2. They all have different forms and they all have different uses. You should just work with the one that you have that makes your math wide open. It makes you more flexible in your mathematics. How many solutions? You have 3 possibilities. You have where they intersect is 1 solution. You're not going to really see this on this right here, but no solution would be if they're parallel lines. You're looking for a solution that works for them. And then a line that lands on itself an infinite number of times would have an infinite number of solutions. That would be like y equals 3x plus 1. And then if I multiplied all those terms by 2, 2y equals 6x plus 2, it's the same line. One is unreduced. That's why you have an infinite number of solutions, because they are the same line. Parallel lines don't intersect at all, no solutions. Intersect in one place, 1 solution. This is the one that we work with the most. You have graphing to find solutions. You have substitution method for finding a solution. And you have elimination as a method for finding solution. The substitution method, you want to isolate one of your variables, and then you're going to substitute it into the other formula. I'll do the harder one, number 79. Which variable would I want to isolate? Which equation? Which variable? Well, if I isolate for x, that means I'd have to shift the y over and then divide everything by 3, and that gives me fractions. I see y. Hey, that's a good one to isolate, because all I got to do is shift the 3x to the other side. Y equals what? When I shift positive 3x to the right, Matthew, what do we get? There you go. Isolated, step 1. Isolate a variable. This equation has 2 variables in it. You can't solve an equation that has 2 variables in it. It's got to have 1 variable. What am I going to do with this then? What method are we working on? Substitution method. I'm going to take the first equation that I solved for y, and I'm going to put it right here. I'm going to put it in for that y term right there. I'm substituting everything that y equals into y. So I have 4x minus 3. That's where I'm substituting in what y is, equals 1. Now if I look at my equation, I have 1 variable. I know how to solve for an equation that has 1 variable. And this is how you solve for equations that have 2 variables. You either use the substitution method or the elimination method. Simplify, and that makes it 13. Thank you. Nothing I hate more than doing an entire problem that's wrong. I appreciate it when you speak up like that. Negative times a negative is positive. And now shifting that over, we get 13x equals 13. Add 12 to both sides. Divide by 13. And there's the first part of our solution. I know that x is 1. A solution means you have an ordered pair. That's right. I'm going to go back to this equation because, look, y is already by itself. Why do I want to go to this equation and have to solve for y again? That's why I put a box around that isolated one, because I always go back to it at the end. X equals 1. I'm going to put it in here. So we have y equals negative 3 times 1 plus 4. Substituting in 1 for x. And we get y equals negative 3x plus 4. Y equals 1. So my solution is 1, 1. Nothing is eliminating here. My x's, I add them up, I get 11x, I get 5y. I need one of those variables to be eliminated. So if I could multiply my equations by something to make them eliminate, I'm going to work on my y's. I'm going to multiply both of these equations. You don't always have to do both. If you look at 80, you wouldn't have to do both equations. I'm choosing the harder of the two. If I multiply the first one by 2, that gives me 6y. What would I multiply the second equation by to make those y's cancel? Negative 3. Negative 3 times 2 is negative 6y. Distribute that onto everything. Now when I add up these equations, I eliminated my y terms. And 14, 24 plus 3 more. You get x equals 1. And we do the same thing again. Go back and substitute into one of the equations to find your y. But the biggest thing was eliminating, getting one of the variables to go away so that we could solve with just one variable. Do your best.